Hi everyone. So in this video we are going to discuss on tutorial 7 on the topic elastic and inelastic collision. So this is question 1. So we read the question first. Two objects P and Q of the same mass approach each other on a smooth horizontal surface with speeds u and v respectively. So P and Q then collide elastically. So after collision, P stops. So what is the speed of Q at that instant? So mention here same mass. So we are going to use the same symbol M for mass. And then the speed U and V, okay, for P and Q. Then they collide elastically. So for elastic collision, so we can use both principle of conservation of kinetic energy and principle of conservation of momentum. Okay, so before collision, P move with speed U given here, and then Q move with speed V. Okay, so they approach each other, so that's mean we can illustrate it like this. Then after collision, so the P is the P stop, the speed P stop, so that's mean we name as the U2 for the speed of P after collision, so U2 is 0, and then Q move with speed, let's say V2. So this is what we are going to find, speed of Q. Okay, so we use principle of conservation of momentum. Okay, for before collision, okay, momentum of P is m times u. Okay, plus momentum of Q is negative mv. Negative because v is opposite direction, so become mu minus mv. Then after collision, the momentum of P will be 0 because the P stop, so that means 0 plus the Q is m times V2. So V2 is what the questions wants. We are going to find V2. So we can rearrange the equation here. First, we can cancel out m. So we get V2 equals to U minus V. So this is the answer. Okay, next we go to question 2. Okay, the figure shows a ballistic pendulum used to determine the speed of a bullet. A bullet of mass m traveling at a velocity of v hits a block of mass m, capital letter. So after collision, the bullet is embedded in the block and the block is displaced through a height of h. So find the speed of the bullet in terms of m, capital M of the block, and then h, the height, maximum height, the block, the pendulum reach, pendulum. Okay, so now we are going to find the speed of the bullet. So that's our target for this question. Okay, we divide into two parts. So the first part, we are going to use principle of conservation of energy to determine the u speed of both block when the bullet hit the block, the pendulum. Okay, so we name as U2, and then both of them reach the maximum height h. So at maximum height, it is understood that the V2 is equals to 0. So we name as V2, final velocity equals to 0. Okay, so we use principle of conservation of energy. Okay, so the total energy involved here is kinetic energy and potential energy. So total energy before equals to total energy after. Okay, before means at the ground. So at the ground, the kinetic energy will be general formula is half mv squared. So the m is mass for both of them. So mass of the bullet and mass of the pendulum. Okay, times the speed is u2 squared. So we are going to find this u2. Okay, then plus the potential energy. So potential energy is 0 at the ground. Then when it reach maximum height h, so the kinetic energy will be 0 because it stopped at the at the maximum height here. And then plus the mgh. So the m is total of mass bullet plus the pendulum, m plus m times gh. Then we can cancel out m plus m. So we get u2 squared equals to 2gh, and u2 is square root of 2gh. Okay, so now the first part, using principle of conservation of energy, we can get u2. Okay, next we are going to use the principle of conservation of momentum for the second part. Okay, so before collision, the mass of the bullet move with velocity u. Okay, and then the pendulum here is stationary. Then after that, when the the bullet hit the pendulum, so they move together with velocity u2. So u2 we calculated already in the first part. Okay, so now we use principle of conservation of momentum. So momentum before will be m times u, okay, of the bullet plus 0 for the pendulum, because it is stationary at before collision. Okay, after collision, they move together, so that's mean the mass is the total of m plus capital M, mass of the pendulum, times the u2. So now to solve this, we can find u equals to m plus m divided by m times u2. Okay, we substitute u2 into the equation here, and so this is the answer. What the questions wants is the speed of the bullet. So this is the speed of the bullet in terms of m, capital letter M, small letter m, and h. Okay, now we go to question 3. Okay, so we read the question. So a car of mass 3,000 kilogram traveling with a velocity of 90 kilometer per hour collides with a stationary car of mass 2,000 kilogram. After impact, they move together with the same velocity. So what is the total kinetic energy of both cars after collision? Okay, so imagine this is the car with mass 3,000. So another car mass 2,000. So the speed U1, let's say we name this as U1, the speed of this car. So 90 km per hour. So another car is stationary. So U2 equals to 0. So this is before collision. Okay, so we convert to meter per second. So 90 km times 10 power of 3 to convert to meter, and then 1 hour convert to second, so 1 times 60 times 60, so we get 25 meter per second. Okay, so now they collide. Okay, they collide, then they stick together. So the total of mass will be 3,000 plus 2,000, which is 5,000 kilogram. Kilogram. Okay, so we use principle of conservation of kinetic energy. Okay, kinetic energy. So total kinetic energy after collision will be half. So the m is 5,000 times the v. They move together with velocity v. So this is total kinetic energy after collision. So we are going to find this v. Okay, we are going to find this v. Okay, so we use principle of conservation of momentum. Okay, so momentum before will be 3,000 times 25. Okay, m times speed, mass times speed, and then plus the 0 because momentum of the second car is 0. Okay, so this is total momentum before, and total momentum after will be this 5,000 times v. So this is second equation we form. Okay, so now combine this both. So 3,000 times 25 equals to 5,000 v. For the this one is for the principle of conservation of momentum. So we equate both of them. Momentum, total momentum before equals to total momentum after collision, and we get the v, which is equals to 15. So we can substitute into this equation to get the total kinetic energy after collision. So v is 15, substitute into here. Okay, we continue on top here. So kinetic energy is half mv squared. So m is 5,000, v is 15 squared, and we get total of kinetic energy after collision is 5.63 times 10 to the power of 5 joule. So this is the answer. Okay, so next we go to question 4. Okay, so question 4. A particle P of mass m traveling with a speed of 6 meter per second approaches another particle Q of mass 4m, which is at rest. So P collides head-on and elastically with Q. So what are the speeds of P and Q after collision? So we are going to find speed both for P and Q after collision. Okay. So before collision, so this is what happened. P with mass m, the speed is 6 meter per second, and then Q with mass 4m and it's stationary. Okay, after collision, they collide elastically, so the P and the Q move with velocity. Let's name as Vp and Q as Vq. So we don't know their speed. Okay, Vp and Vq. Okay, collide elastically also means that we can use principle of conservation of momentum and principle of conservation of kinetic energy. So using the principle of conservation of momentum first, so this 6 times m plus 0, momentum of the q0 equals to, after collision will be mvp plus mvq. Okay, so we cancel out m. So simplify the equation, we get 6 equals to Vp plus 4Vq. So this is equation 1. We form from the principle of conservation of momentum. So using the principle of conservation of kinetic energy, so the total of energy before will be, kinetic energy will be half mv squared. So half m, speed is 6 squared, plus kinetic energy of q will be 0, equals to total of kinetic energy of P and Q after collision will be half mvp squared plus half m for Q is 4m. Okay, Vq squared. Okay, so we form another equation. Cancel all the half, simplify this equation, cancel also m, and we get 36 equals to Vp squared plus 4Vq squared. So this is equation 1 and this is equation 2, and we can solve Vp and Vq using a simultaneous equation. Okay, so this one we rewrite as Vp equals to 6 minus 4Vq, and then we substitute into here. Okay, just now this one we substitute into here, so we can get 36 equals to, simplify this. So 36 equals to, expand the bracket here. Okay, then plus 4Vq squared. So can 36 here can be cancelled because 36 minus 36 is 0. So we get 0 equals to negative 48 Vq plus 20 Vq squared. So we simplify, we get 0 equals to negative 12 Vq plus 5 Vq squared. Okay, so factor out Vq, so we get in the bracket negative 12 plus 5 Vq. So Vq is 12 divided by 5. The answer is 2.4 meter per second. So this is the answer, okay, for Vq. Another one, Vq equals to 0. It's not logic. So the acceptable answer is, the accepted answer is 2.4 meter per second. Okay. So next, to find Vp, so we substitute 2.4 into the first equation. So we get Vp negative 3.6 meter per second. So negative means that P move in the opposite direction. Okay, so negative 3.6. So that's mean this one we change to this direction. Okay, opposite direction. Okay, so done for Vp and Vq. Okay, there is another method. You can use the formula of we derive that day we discussed in the class. So the formula of VA equals to MA minus MB times UA divided by total of the mass AB plus 2MB UB divided by MA plus MB. This one is for VA. So for VB will be MB minus MA divided by total of masses times UB plus 2MAUA divided by total of their masses. Okay, so for the VA, we substitute the mass M minus 4M and then M plus 4M times the speed of A is 6. This one 6. So then the 2MB, MB is 4M, the mass of MB. So the UB is 0. So that means this part is 0. So you solve, you get negative 3.6 meter per second. Okay, so same answer as the previous method. So if the VB, you substitute the value for M and M into here. Okay, so UB is 0. Okay, then UA is 6. You get VB 2.4 meter per second. Okay, also same answer as the previous method. Okay, so there are two methods you can use. Okay, now we go to question 5. A radioactive atom which is initially at rest decays into two particles of masses m and capital letter M that move with velocity u and v respectively. So calculate the ratio of the kinetic energy of the particle of mass m to the kinetic energy of the particle of mass capital M. So we are going to find the ratio of kinetic energy. So particle with mass m first, then divided by particle of mass capital letter M. Okay, so how to illustrate this? So we draw this diagram. This is before collision. Both of them has mass, okay, m plus m. Okay, this one at rest. Then after that, they recase, so they split into two. So with mass m and capital letter M, okay, and they move with velocity u and v mentioned in the question. Okay, so now we use principle of conservation of momentum. So before collision, the particle, the atom is at rest. So that's mean before momentum before is 0, total momentum before collision. So after collision will be m times u plus m times v. Okay, so v will be equals to negative mu over m. Okay, so now the ratio of kinetic energy. So after calculate the V, so the reason we use principle of conservation of momentum is to find V, where we are going to substitute this V into the formula of kinetic energy half mv squared. So V we get from principle of conservation of momentum. Okay, now using kinetic energy formula half mu squared. This one is for mass m particle with mass m divided by half m capital for particle with mass capital M. So half mv squared. So this is the ratio. So you cancel out the half. So at the m u squared. Okay, u squared is given here. Then m. So this this v squared you substitute into the equation. Okay, negative mu over m squared. Okay, now we can cancel out u squared. So cancel out mu squared. We can cancel out mu squared. Also one of the m. So we get the answer. Bring m up. So we get m divided by m. Okay. So go back. So this is the answer. Okay. Now we finish. Okay. So we finish our tutorial 7. Okay. Bye bye.